Okay, guys, so there's still one thing left for me to do, but it's kind of short. So, if you look up, please. The last thing I want to look at is a very, very important type of simple harmonic motion called the pendulum, which Saeed, as you called it earlier, the clock, you know, with swinging left and right. This is called a pendulum. Okay. Now there's a formula here for a pendulum. The formula, okay, so I'll just make sure we're all listening. So listen carefully, please. This is really important for your lab, because lab, which number? Lab number 2 is about this topic, the pendulum. Okay. Now, if this pendulum, for example, was 1 meter long, I actually can know how long it will take for it to swing back and forth. The time, I think it's going to be roughly 2 seconds, I think. It'll take about 2 seconds here. And the reason I know that is there's a formula for the pendulum. There's a formula that will let you tell the time if you know the length. And the formula is T equals 2 pi. You said you did this experiment, didn't you? Yeah, 2 pi root
L over G.
L over G. So I want you to take out your calculator, and I want you to put in L as 1, and tell me what the time is. How long it takes to do one oscillation, one cycle. How long does that take?
2 seconds.
No, in my head I think it's...
It is about 6 seconds.
I can't be that accurate, can I? I just did it in my head.
2.006.
Oh, not bad. Alright, 2.006. So what about if you make it 10 centimeters? 10 centimeters. What's the time then? Can you type it in? Do you want to type it in, Louise? So this formula will put the length as 0.1. What is it? It's very small, isn't it? Because it's moving faster. Lastly, if you had a really big pendulum of 10 meters, what's the time? 10 meters, what's the time to swing? 6 seconds about? Yeah. So, as the pendulum gets longer, it takes more time to swing left and right. Okay, because if this is big, then this will be big. Okay? So what I'm going to do with you now is I'm going to prove this formula. And the proof is important because you need the proof in your lab report. Okay, so this proof is important for your lab report. Okay? Yeah? I'm going to prove it now in a moment. What are you asking me? No? Okay. Okay, so I'm going...
For personal, is it?
For what?
For personal. For individual requests.
Yeah, so the report you write for me, you must include what I'm going to do next, the proof I'm going to do next. So what I'll do next, make sure you write it clearly in your notebook. Okay? Alright, can I go down? Yeah? Well, I'm going to draw this again, so don't worry. So, we have our pendulum. This angle here is theta. And there are 2 forces here. The first force, which is mg, and then the second force here, which is the tension T in the rope. This T, I can break it up into a force this way. Well, hang on. A force this way. Not the T, I mean to say the mg. Now look carefully. If this is theta, then this angle here is also theta. If this is theta, then this is mg cos or sine? Cos or sine?
Yeah,
cos theta. And this one here is mg sine theta. So first draw that. No, I need to go down though. I'll do it to the side. So if I draw the ball again, what force is making it go to the left? mg sine theta. And the force that's roughly going up, I know it's not, I know it's not going up, it's at an angle, but roughly going up is t. And then going down here is mg cos theta. Now the problem is I drew my angle too big. I should have drawn it smaller so it looks more up, okay? So I'm just saying roughly going up is t, down is mg cos, and left is mg sine. I just moved this over to here. It's a separate picture. Now this t and this mg cancel because it's not moving up and down, it's only really moving left and right. Okay, so you're left with now this picture. And this is going to the left, so I'll make it minus. You know from Newton's second law that F equals ma. But from here, you know that F equals minus mg sine theta. So therefore, ma equals minus mg sine theta. So then A equals minus G sine theta. Now this is important. Look, I know when this is moving left and right. Can you look at my hand, please? Look. If you look here, I know when this is moving left and right. It is moving up and down a little bit, isn't it? Because when it goes left, it goes up, and then when it goes right, it goes up. So what I'm doing here is I'm saying it roughly stays the same height. But we know it doesn't. We know it goes up like this on a curve. But I'm saying roughly it's like a straight line. So I know and you know that this here is curved. But we can say roughly it's a straight line, which I'll call it x, the displacement x. But we know it's not straight, okay? Now, what does sine theta equal here? It will be x over the length here, x over L. Do you remember this? Just be clear. If this is y and this is x and this is h and this is theta, sine theta equals y over h, cos theta equals x over h. In other words, sine theta is the opposite divided by the longest side. Like I said, we'll do this in maths class, so don't worry too much about it if you're not so sure. But we have this. Sine theta is x over L. So if I go down, I can use that here. I get A equals minus gx over L. So I get A equals minus g over Lx. Can you see that's a minus there? Sorry. Okay, now call g over L omega squared. So just call that g over L omega squared. Or if you prefer, let g over L equal omega squared. Then I can write this formula as A equals minus omega squared x. Does that formula look familiar? I gave it to you at the start of the class. In fact, I said this is the definition of simple harmonic motion. But of course, you knew that this motion would be simple harmonic motion. Anyway, the key thing I'm trying to say is, if you want to think about it like this, let me go back, sorry. You can also think about it like this, but A equals minus omega squared x. Therefore, this piece here must equal omega squared. So you get omega squared equals G over L. So what does omega equal? Root G over L. What is the formula for time? 2 pi over omega, which here is 2 pi over root G over L, which finally is 2 pi root L over G. So the proof is finished then. So I know it's a little bit difficult, but we proved it. So if you tell me the L, I can tell you the T. Or if you tell me the time, I can tell you the length. So for example, if I know it takes 2 seconds to go like this, then I know the length is 1 meter. I did that one at the start. If I have 1 meter, then I know that the length is 2 seconds, and because I can use this formula. So if you know L, you can get T, and if you know T, you can get L. So it's a useful formula, a special formula. Okay, and it's important for lab number 2, which we'll talk more about later. I'll just give you one example to do for this formula. I just want everybody to do question 1 on the last page, and then I'll do it on the board, just to make sure you know how to use the formula. So just question 1, please.
What's the difference between the simple pension formula and the complex pension formula?
Simple and compound. The compound one is one where you have a moment of inertia in it. Yeah, the formula is square root I over mgh for the T. We don't do that one though.
I don't think we didn't do it either. I think we did it in finance, but we don't very far in it. Inertia numbers.
I like the inertia question in the exam. It's a pity that it's not done more.
Yeah, I think it's a bit.
Number 8.
Yeah, I think it's a bit overcomplicated.
No, it's the thing, it's not. It just seems like that. But if you actually did the classes and practiced them, you might think to yourself, oh, what was the deal all along?
I think what happens...
It's complicated probably because it's so different.
That's the same thing with hydrostatics, though.
True, and that's why people don't usually do it.
I think the reason we didn't really do inertia is because it's the last topic we did, so...
Yeah.
We all kind of decided what we're going to do anyway, so
Yeah.
Just teach us for the hell of it.
Yeah. Okay, do you have the first one done? So, what does the question give you in number 1 here? What do you know?
Length.
The length, what is it?
0.5.
Yeah. So they want the time. It's 2 pi root L over G is 2 pi root 0.5 over 9.81. So what does that equal? 9.4. Oh, by the way, in this book they use 9.8 in this book here. So if you use 9.8, what do you get? 1.4 here? 1.4 seconds. Okay. Pretty straightforward, isn't it? I know there are a few questions here and they do kind of get more difficult. So I would say it's probably enough if you can just do 1 to 5, I think. Yeah, 1 to 5. Yeah. Okay, so that finishes the mechanics part of the course. So 1 down, 5 more to go. So we're 1/6 finished, okay? 5 more sections to do. The exam tomorrow could cover anything you've seen so far, anything on mechanics, including this, including class number 1,
Include this one?
or including everything, everything. So it's a 1-hour test tomorrow. Okay. I think I did, if I remember, 6 small questions and 1 large question. It'll be tough. There's a lot to do in 1 hour. Okay? But I might, I don't know. I'll see how you do. It's not a problem. It's a big test and there's lots to do. So don't worry if you don't get it finished. Okay, just do as many as you can. All right. You know, and it can be on anything we've done so far. Everything so far. Okay. Okay. Yeah, nothing else to say then.